you're Jay Tate. You're the director of the Spaceguard Centre. I beg your pardon, and
That's right.
that's based in Powys in Wales, in the United Kingdom.
Yep.
So, what sort of stuff does the Spaceguard Centre do?
We do three things really. The first is education with a small e. That's educating the public, grown-ups, if you like, on the impact hazard and how we can deal with it. We do education with a big E, i.e. schools, colleges, that sort of thing. And thirdly, of course, we do the proper stuff. We actually make observations of asteroids and comets, and our data is used by the Minor Planet Center in the States to confirm or calculate the orbits of the objects that we observe.
So you don't do this in isolation. The data that you collate, it's shared with these other observatories and other projects across the planet. Is that right?
Well, yeah, there's an ever-growing network of organizations that are now realizing that the near-Earth object hazard is both real and quite serious. Mainly, of course, it's coordinated by NASA in the United States and the European Space Agency.
And what sort of objects are you looking for?
Well, at the moment, we're not into the search game, we're in the tracking business. The discovery of new objects is mainly the task of the big professional surveys, mainly in the United States, but spreading nicely now. But once you find something, you need to know where it's going. And for that, you need to track it for a period of time. And right now, that's the game we're in. We'll be moving on to a search program once the big 24-inch telescope is up and running.
And is that so? Do the NASA and the other big space agencies, do they identify potential hazards and then you monitor them? Is that how it works? You track them to look at their orbit?
Well, initially, of course, you've got to track anything that's found to find out whether it's going to be a problem or not. If it is going to be a problem, i.e. a close approach or indeed a collision, then NASA and the European Space Agency will deploy much bigger, better telescopes to have a much closer look so we can calculate precisely whether or not it's going to be an issue. But each of these things has to be tracked initially.
Yeah. How does NASA work out, or ESA, how do they work out what parts of the sky to look for to identify objects? Can they look at all of the sky at once, or do they look for areas which have a greater chance of generating these asteroids?
Well, it's actually very simple. I mean, you should watch the whole sky, no doubt about that. And there are programs now that can do that reasonably efficiently. But the vast majority of the threat comes from the plane of the solar system, the ecliptic. So most search programs will look at the ecliptic, the line in the sky where you find all of the planets and most of the asteroids, plus or minus a few degrees. But there are now all sky surveys that can cover the whole celestial sphere.
When you mention the ecliptic, do you mean, is that the asteroid belt?
No, the ecliptic is a line in the sky, which is the plane of the solar system. The solar system's like a flat disk around the sun. So when we look at the sky, we see, in effect, a line across the sky where you will find, give or take a little bit, of course, the planets and most of the asteroids and comets.
In terms of categorizing or how much of a threat objects are, is there a difference between comets, asteroids, meteorites? Do they all present an equal threat to Earth, or Are they
Well, of
different
course,
in their nature?
a meteorite isn't a threat at all. It doesn't become a meteorite until it's actually on the ground.
Yeah,
So you don't see meteorites in the sky.
meteors.
Um, Asteroids and comets are both treated in very much the same way, although their physical properties, their origin, and so on are very different. But the actual mathematics to calculate their orbits is precisely the same.
Mm. And if there was an object that potentially could be on a collision course with the Earth, what plans do current governments have if it was found that it would impact the Earth to defend the Earth in terms of deflecting or destroying the asteroid? Are there any plans that different governments have?
There are plans. Any such effort would be coordinated by the Committee of the Peaceful Uses of Outer Space from the United Nations. But the only nation that's really got a grip on this one is the United States. In the UK, of course, there's diddly squat, nothing at all. The UK does not regard this as an issue at all. So it's all down to the United States at the moment. And of course, they've just practiced for the first time changing the orbit of an asteroid.
Yeah, that we're talking about the DART mission, is that correct?
Yeah,
DART.
absolutely. Yeah.
And that did successfully deflect or has changed the trajectory of the asteroid. Is that right?
Absolutely. It seems to have done it rather more than we'd expected as well.
But I think the one caveat is you have to identify the asteroid with enough time to deflect it. Is that correct? You need to
you've got to find it first. Yeah. So the first thing to square away is your search program, detection, because without that, of course, everything subsequently falls apart. So it's a three-step process. You've got to find them, you've got to track them, and then you've got to make them go away.
Do you feel that attitudes towards the threat that these objects could have on Earth has changed in the scientific community? Do you feel like before it was maybe for movies, Hollywood movies, and frowned upon, it wasn't ever seen as serious science? Has that changed or evolved at all?
Well, when I started in this game about 25 years ago, we were down there with flying saucers and little green men. That has significantly changed over the last quarter century. Not, I have to say, helped by Hollywood. I mean, the three blockbusters, Deep Impact was deeply boring. Armageddon was laughable. And quite frankly, the latest one, Don't Look Up.
Okay.
Well, that's two hours of my life that I'll never get back again.
There was that film from the 1970s with Sean Connery, I think, when the USSR and the US fired nukes. I don't know if you remember that film at all.
Meteor, yeah.
That's the one.
Yeah.
But yeah,
you can hardly see my eyes rolling behind my spectacles, but yeah.
that wouldn't have any effect, would it, if you were to fire some nuclear missiles? Assuming you could practically do it, wouldn't that just make the situation worse by creating loads of little meteors or asteroids?
Well, there are two ways of using a nuclear device. Obviously, it's not a weapon in this context. You could use it as they did in Meteor to try and break the thing up. Well, that's simply turning a bullet into a shotgun blast. That is a complete waste of space.
Mm-hmm.
The best thing is to detonate some distance away from the surface and use the heat and the radiation to ablate or vaporize the surface, which then jets outwards and acts like a rocket motor, pushing the thing in the opposite direction. That's perfectly possible.
And in terms of what we know now, are there any asteroids or objects which we're concerned about?
None that we know for sure are going to hit within the next century or so, which probably means the next one to hit is one we haven't found yet. But both NASA and the European Space Agency produce a risk list. These are objects with small but non-zero hit probabilities. For example, this morning, the ESA risk list had 1,138 objects on it.
Mm. And what process do they categorize the risk? Is there a criteria that they use to assess the risk that they possess?
It's simple sums, basically. You can work out the probability of a hit fairly simply. As you make more and more observations, that sum gets more and more precise. What normally happens is that we find something, there is a hit probability, probably fairly low. You make more and more observations, and the uncertainty ellipse gets smaller and smaller. But if the Earth's still in it, then of course the hit probability goes up and up and up. And then 99 times out of 100, you get a set of observations that reduce the size of that error ellipse to the extent that the Earth pops out of it, and consequently the hit probability drops to zero. So your probability will go up and up and up and up and up and up, and then boom, down to zero. Unfortunately, the press tend to pick it up on the up, when it's at its worst.
Yeah.
And this is when you get the Daily Fail coming up saying, oh, we're all going to die on the 23rd of whatever next year. What they don't do is wait for that extra 24 or 48 hours when the thing drops to zero, and they never report that.
Yeah. In terms of governments and their attitude towards these near-Earth objects, as far as you're aware, if we take the UK government, do they have a escalation process? Do they have any protocols in place if such an event was to happen?
What you mean in the UK?
Yeah, does the UK government have a policy or a process?
Yeah. No, absolutely nothing at all. This doesn't even appear on the Cabinet Office National Register of Risk. So as far as the UK is concerned, no, it's not going to be a problem.
Yeah. It is interesting, though, talking about the balance of the argument, because there are theories that it was asteroids and other objects from outer space that contributed to the evolution of life on the planet. So it's not all doom and gloom. Obviously, there is the chance that it could hit us and create an extinction level event. But also on the other side of the coin, there is a lot of scientific thought that it was asteroids that helped with the evolution of the species and the Earth. Is that right? Or
well, I think it's almost certain that the complex organic compounds needed to develop life almost certainly came from probably comets. We find incredibly complex organic compounds in asteroids. We find them in comets. In fact, we found, I think, just over 22 amino acids in the skin of a comet. So almost certainly those complex organics were brought to the Earth by asteroids and comets. As far as the mass extinction thing's concerned, well, fine. I look at the dinosaurs, they're dead because they didn't have a space program. It rather depends on your view of whether protecting our species is worth it or not.
Do you think it's a case of when, not if, in terms of being hit by an object that could cause an extinction level event? Is that something that will happen one day?
Oh, it's absolutely inevitable. I mean, the probability of that happening is precisely one. What we don't know is when. But for the first time in the history of the planet, we've got a species that has the ability, now proven ability, to make the thing go away.
And do you think unless we do start exploring and colonizing other planets in the solar system, we're doomed to be at the mercy of one of these extinction level events sooner or later if we don't leave the Earth and start populating other planets?
Well, there are two quite opposed thoughts on this one. Firstly, of course, you can't spend the whole of your life in the cradle, which is in effect what we're doing at the moment. You need to get out and find and make your own life somewhere else. The solar system might or might not be the place to do that. We're never going to have anywhere that's like the Earth. So that's difficult, not impossible, but difficult. Perhaps the Starshot initiative has got the right idea in looking at neighbouring stars. That's frankly for someone else to worry about. But the other view is that it's all very well to say, well, let's leave the Earth and go somewhere else. My view on that is it's a bit irresponsible. If we're going to trash this planet in the full and certain knowledge, we can often find somewhere else. I think that's actually a little bit immature. I would much rather settle down and say, well, look, we are here at the moment. We better look after it. I don't think there's an easy way of saying, well, the Earth is not going to be very nice, so we'll poke off and go somewhere else, and we'll trash that as well.
How how many years would you say we are away from having a credible defense against near Earth objects?
How long's a piece of string?
Uh, has the dart moved things forward? Has it proved
Darts move things forward, very much so. It was only a little spacecraft moving a little asteroid, but it has proven the system. We now have one shot in the locker. We also have ideas on many, many other ways of doing it, some long-term, some short-term. But of course, as an ex-military person, I always work on the principle that if you haven't practiced it, you can't do it.
Yeah.
But I do know that there are, many moves afoot, many plans, both at NASA, the Planetary Defense Office, and at ESA, to try other methods. So we've got more than one system, if you like, that we can use.
Do you still feel though that attitudes need to change in terms of the government of the whole of the different nations in terms of seeing this as a legitimate threat and also putting funding towards these projects so they do evolve and they do reach their potential and not just stay on just talking about them, that they do evolve to a point where they are real?
Yeah, it's got to be a step process. You can't do it all at once. That would both look silly and be silly. What nobody is suggesting here is that we have, a great big organization with loads of rockets fizzing on the pad, ready to go, and fingers hovering over red buttons and that sort of thing. What we've got to do is square away the search process first. Imperfect as that will be, you can never guarantee 100% security. So there will be things that leak by and pop up unexpectedly. But if we can reduce that number to a manageable extent with a decent, coordinated international search program, then we're halfway there. Because what you need is notice. If we find one that's coming, that's going to hit in a month's time, there is nothing you can do about it. If we know it's going to hit a year or two, perhaps a decade in advance, well, then there's plenty we can do about it. So we've got to get the search side sorted first, and big steps are being taken on that right now. Not necessarily with telescopes that are dedicated to looking for near-Earth objects, but we can siphon off data from other surveys who are doing other things and use their data. A photograph of the sky is a photograph of the sky, let's face it. If they're looking for distant galaxies or black holes or things, fine. But we can have a look at the rest of the photograph to see if there's anything of interest to us. And that is precisely what's being planned at the moment.
That's the end of the podcast, Jay. That's been fascinating talking about the work that the Spaceguard Centre does in Wales. It is fascinating, and I think a lot of people's attitudes are changing. Not just because they read the Daily Fail. I think people now are a lot more. They read things, and I think it's reassuring to know there are programs out there that aim to search for these objects.
Well, we're getting there bit by bit, but it's a long and slow process. I just hope the process finishes before the next one shows up.
Me too. Thank you very much for talking to me.
Not a problem. Thanks for having me.
Bye bye.
Bye now.